Welcome to the Implementing Database as a Service with Oracle Real Application Clusters and Oracle Quality of Service Management. I'm Mark Scardina, Director of Product Management of Oracle Quality of Service Management, which is part of the Oracle RAC development group. Today we're going to be discussing database as a service, but not from a traditional point of view. We're not going to be talking about service catalogs. We're not going to be talking about templates or self-provisioning portals. What we're going to be talking about is how do I actually implement the back end of this type of deployment, and how do I manage it in runtime? What technologies do I make use of in the Oracle stack to actually implement database as a service and manage a real deployment? As a foundation of this type of private database cloud, we have Oracle RAC databases. Now, Oracle RAC Database has been a technology that has been in existence for the last 15 years and has evolved from a pure performance scalability platform to one that introduces high availability, and now with 11.2 and 12 also introduces flexible deployments as well as quality of service management. And that is going to be the foundation of this database as a service deployment. But why do we need that as a foundation? Well, if we look at the requirements of database as a service, we're hosting competing workloads. And those workloads actually are needing to meet certain service levels because our customers are going to want to guarantee that their performance is met by giving up their siloed application stacks and deploying them on a service architecture. To do that, we need to have SLA management, and behind SLA management is the ability to both monitor and trade off resources. Most data centers do not have an infinite supply of resources, so that means I have to have just-in-time resource allocation available to my platform in order to meet the needs of these competing workloads and maximize my IT spend at the end of the day. And that's where the entire stack with Oracle RAC and Quality of Service Management comes into play. Now, why is this important? Well, today it's no longer the software stack or the hardware that fails. Failures are predominantly due to workload surges. I have to be able to plan for those surges. I have to be able to react to those surges in real time. And as a result of that, I have to have a flexible deployment model which allows me to monitor real-time performance as well as make resource adjustments in real time. So if we look at the high-level objectives for my data center hosting a database as a service deployment, I have to be confident that when I have sufficient resources available, that they can all be allocated where they are needed so that I maintain all my SLAs. However, equally important is when I have insufficient resources available, I need to actually be able to prioritize my work in such a way that my most business critical applications and services are maintained, and I'm able to shut down the less business critical ones or slow them down. And under all conditions, I want to ensure that I do not lose hardware resources, because then I take a real outage. So with those objectives in mind, let's look at the Oracle technologies that need to come into play to deliver on these objectives. First off, I need a monitoring framework. And this is a preview of a dashboard we're going to be talking about in detail a little bit later. But to give you an idea of what the goal here is, I need a really easy to comprehend dashboard. And we'll be talking about this as we move forward. But this is the Quality of Service Management dashboard, which will give you a view at a glance of the health of your database as a service deployment and how well you're doing against your service level objectives and whether there are resource trade-offs that need to be coming into play. Before we get into that, though, let's talk a little bit about the new technologies that were introduced to help support this effort. First off, we need the concept of a policy. We need your system to actually be able to be managed in a way that can adapt to the different customer demands. And so a general overall policy set is a requirement for such a system. And whether or not you're in a maintenance mode, a weekend mode, a daytime mode, you need to be able to have your performance objectives or your resources allocated to meet those demands up front. And so we have a quality of service management policy set that drives this back-end deployment for database as a service. And we'll be talking about this in detail here. The first item in this policy set you'll see here is server pools. Server pools are a very critical technology that was introduced in 11.2 and are basically sets of resources, physical resources, that are within a single cluster but may be logically divided up. Note the dotted lines in this slide. I can move resources between these pools, which I couldn't do if these were separate clusters. This gives me the flexibility to deploy larger clusters but still keep some level of workload isolation. I can deploy multiple databases across these pools, thereby govern the priorities and business criticality of my workloads, which we'll talk about in a few minutes. The key takeaway here is that I can take and build bigger clusters, yet still get the isolation that I would get if I had siloed clusters that I could not share resources with. And this is a key technology, and we'll talk about how that fits in. We also introduced a new form of database management in 11.2 and have expanded on it in 12.1. Traditionally, we've managed databases with what we call administrator-managed approach, where you specified for each individual database which instance, which node it ran on. Very, very exact, very static, very difficult to change. Obviously, that does not play into a database as a service play where I need to be able to have flexible resource placement. I need to be able to move things on demand. I need to be able to adjust my resources. So in 11.2, we introduced this concept of a policy-managed database, once again a RAC database, but where I can specify my resource requirements based on expected workloads. That is, how much my customer needs. I can also rank different pools and so that I can govern gold, silver, and bronze level services. I also have the ability to only start the number of instances I need at any one time, so I don't have to over-provision the cluster or the databases to make sure that I'm still highly available. And with the goal here that we remove the hard coding and the static high level of management necessary in the old style to give you a much more flexible platform to build and deploy your database as a service. So functionally, there is a big difference in the operation of these two things. In an admin managed case, which is 11.1 and earlier databases, you didn't have control over your startup order of the services that you were provisioning on your databases, nor the instances really. There was no guarantee that your most critical services would actually survive an outage, or your most critical databases. You could have cascade failures that result in a total cluster outage because there was no way to isolate failures. And finally, it was very difficult to manage because of the static control that was only offered for service placement and instance placement. Policy managed changes all of that. Now you can have policy-based startup order, ensuring that your most business critical services start up first, your gold services, for example. You can also guarantee what the last services are standing should you have an outage, something that's very critical in any type of database as a service deployment. Also, you have the ability to allow for failover situations not to cause cascade failures, but to actually cause less business critical workload to shut down and let the more business critical workload survive. And finally, there is complete dynamic control over the services and their performance by the ability to grow and shrink server pools and change the provisioning on the fly. For example here, I've got two pools, where I've got a gold pool and a silver pool. And we also have a free pool. The free pool is there all the time by default. Notice another thing is each pool has a property. 3 of them actually. One is the minimum number of servers, the next one is the maximum number of servers, and the third one is the importance of that server pool. Now these properties come into play when I go and place servers into the cluster. So as servers join the cluster, these properties are read by the Clusterware and actually used to place the server. So for example, servers always come in through the free pool, but since no resources can run in the free pool, Clusterware needs to figure out where to put this first server. So what it does is look for which server pools minimums are not being met and which is the most important server pool whose minimum is not being met. So in this example, that server pool is the gold server pool. So we're guaranteed that that first server that joins the cluster is going to land in the gold server pool because it has not met its minimum. Now when the second server comes into play, by the way, the services will automatically be started when that server joins the pool. And so we get service pull-up of that database when the server joins the pool. So services are running inside the server pool and are attached to the server pool. So now when I get my second server into play, it also gets evaluated. And because my minimum is still not met in my gold pool, I'm going to actually place that server into my gold pool to satisfy its minimum. If my minimum had been 1, it would have been moved over to the silver server pool. So as you can see here, I can control exactly the startup and joining of servers to my cluster and what services get started up as a result of this. So there is not any type of service clumping that occurs. So now when a third server joins the pool, since I've met my minimums and silver pool has not met its minimum, I'm going to see the third server into the silver pool and it's going to start up its services, and then finally the fourth server comes in and it's going to start up its services. So as a result, I have a very specified startup order, something I couldn't do pre-11.2 and is only available through policy managed deployments. Equally as important is the last service standing. Just like the gold server pool is the most important pool with regards to startup order, it's most likely the most important pool with regards to failures. So should I have a failure, what do I want to have happen in this type of environment? If I lose my one of my gold servers, do I want to have all the workload land back on the remaining server in the pool? No, that's my gold pool. By specifying its min at 2 and its importance greater than the other pool, what's going to happen is I'm going to actually shut down the workload in the other pool and start up the gold workloads and services in this pool. So I've shut down my less business critical work to support my gold pool and my more business critical work. Thus, I don't have cascade failures, and the result is I maintain an ordered priority to my workloads and continue to meet my most business critical objectives. Should I have a second failure, once again, since the min is still 2, I'm going to actually totally shut down my silver workload and preserve my gold workloads. Now, obviously, if the min was less than 2, I would still keep the silver pool alive because I met my min equals 1 in the gold pool. Policy Manage gives you that flexibility to actually lay out your cluster in a way that you can satisfy the requirements of database as a service. But let's look at another very critical thing. We talked about just-in-time provisioning. And so we have situations where I might have to respond to demand surges, and they may be without notice. So what can this type of deployment do for me? Well, the first thing it can do is it can dynamically size the pools and give you resources on demand. So in this particular case, I've got 2 pools, 2 servers in each pool. Should I have a demand surge, I can actually cause manually or through QoS management a server to join the gold pool at the expense of the silver pool to keep my gold pool's objectives being met. Something that I can do instantly with only a couple of minutes transition time, and it's nowhere near what it would cost if I had to physically add a server to the cluster. Additionally, should I want to add a server to the cluster, it can therefore get placed back in the silver pool and restore the silver pool to full capabilities. So I have 2 options there. One is the immediate one to respond just in time to demand. The other is a more static one, which allows me to fully provision if this turns out to be the new level of resources that I need. Another real critical issue is when we are dealing with evolution of hardware. Many customers have different versions of hardware, and they want to be able to make use of them in a heterogeneous cluster. Well, in 12C, we introduced this capability by actually giving you the concept of categories. You can actually gate server pool membership by specifying a category for the actual server. So in this particular example, we've got 2 types of servers. One is a newer generation 16 CPU servers. The other are older generation 12 CPU servers. And so what I want to do is ensure that my gold server pool gets the newer servers. And so by giving it the server pool a category designation of 16 CPUs versus the silver pool of 12 CPUs, when a server joins or starts up, it will go to the appropriate pool. I don't have to manually allocate it. So when a 12 comes along, even though I haven't met the minimum requirement for the gold pool, it will land in the silver pool. And likewise, when I finally get a gold quality server, it will now join the gold pool, and then finally my 4th one will join the silver pool. So I can actually use a number of attributes of the servers, such as memory.
We can stop and make a note of that. Okay, you want me to roll back and we'll retake that?
Yeah. Okay.
Go back a little bit.
Edit at what number? Okay, that's right.
Slide 14.
Okay.
Okay.
And let's go ahead and try to find the top of slide 14.
Okay, I went back a little bit, see if we're good.
Even though I haven't met the minimum requirement for the
You
gold.
want to go all the way to the beginning?
No, back a little
No, slide 14.
Yeah.
Okay, hang on. Let's find it.
Take 14 from the top.
Particular example, we've got 2 types of servers. One is a newer generation 16 CPU servers. The other are older generation 12 CPU servers.
Okay, coming up.
And so what I
Top of
want to
slide
do is
14.
ensure that my gold server pool
Lift your
gets
hand
the
when you're
newer
ready to go, and I'll-
servers. And so by giving it the server pool a category designation of 16 CPUs versus the silver pool of 12 CPUs, when a server joins or starts up, it will go to the appropriate pool. I don't have to manually allocate it. So when a 12 comes along, even though I haven't met the minimum requirement for the gold pool, it will land in the silver pool. And likewise, when I finally get a gold quality server, it will now join the gold pool, and then finally my 4th one will join the silver pool. So I can actually use a number of attributes of the servers, such as memory, such as location, such as labels I create myself to govern what pools those servers can join, and therefore give me much more flexibility in how my resources get allocated to the pools. Finally, we have a situation where many database as a service deployments need singleton support. And some of these singleton supports doesn't require those singletons to fail over. So how do I manage that? Well, we have RAC 1 node. Any RAC licensee can deploy a RAC 1 node deployment. And so instead of the admin managed approach, which would cause a failure of databases to collapse on top of each other, you can actually put groups of RAC 1 nodes into a single server pool of size 1, and all they'll ever do is restart there. You won't have them collapse. If you want them to collapse, they can, or if you want them to steal a server, they can steal a server. So for example, I can have a set of pools where min equals 1, and it would steal a server from a less important pool. Or I can set min equals 0, and the servers will just restart the instances. So I get to do it both ways with RAC 1 node and policy managed. Needed flexibility when I'm deploying database as a service. Now in 12c, we introduced a new concept which seems ideally suited to database as a service, and that is multi-tenant databases. Multi-tenant has the advantage, obviously, of not having to replicate database instances on the same physical node, but just use something that we call pluggable databases, or PDBs. And in fact, this multi-tenant deployment actually uses server pools and policy managed as the default deployment. So for example, I can set up the same application stack across 3 different pools, the same single multi-tenant database, but have my gold pool of applications, have my silver pool of applications, and have my bronze pool of applications, and have PDBs in each one, and still have the same availability characteristics I talked about with the physical servers. So the result is it's an ideal fit for deploying multi-tenant databases to support database as a service. Alternatively to this gold, silver, bronze model, I may have a requirement to offer my services in consistent groups, which may have similar work characteristics or similar security characteristics. And so once again, the server pool model allows for me to group my PDBs into like application stacks that are either departmental or external or have higher level of security. And the bottom line is that policy managed database deployments give me that flexibility to offer this type of deployment in a database as a service manner. This screen here is a screen from the QoS management policy set editor that's built into EM Cloud Control and shows you the server pools that we were talking about and how you can actually select them as management entities in your policy set. If you recall, I had a server pool block in that policy set, and this is where you'd specify which pools were going to be covered in your policy. And notice there's a min, max, and importance for each pool and their current value. The next element of this policy is something we call performance classes, and these you can equate to your services, the database as a service. But they're not necessarily a single database as a service. These are groupings of like workloads that you want to manage together. So for example, if you have a set of LDAP services that you are hosting in a DB as a service manner, you may want to manage them as a group instead of dividing them up into individual workloads. The bottom line here is these performance classes give you an entity which you can track. You can track its performance objective, you can track its service level, and you can also set performance objectives on it. So it's a way in which to categorize your workloads and make them easier to manage. The hardware stack and software stack together in 11.2 and 12.1 actually surfaces all of the known services in a self-provisioned manner so that you can start off with a policy set that actually is ready to go with the services you've already defined, and then you can edit from there. So this is a screen from that editor that talks about the individual performance classes and how they're set up. You'll notice on the left that there is a service associated with each performance class, and that is one or more services. And there are additional parameters that you can put in should you desire to segment your service offering. So you can use module, action, username, or program name to further delineate that service offering. The bottom line is you specify what it is in each performance class, and then the set of performance classes are included in the policy set that is actually pushed into the quality of service management server to actually manage the cluster at runtime. The third item is performance policies, and that's really where the meat of the action is. This is an ability for you to set multiple policies for which to manage your deployment in a way that continuously can meet your business objectives. It allows you to rank not only the server pools, but the performance classes within the server pools so that you can ensure that your most business critical workloads are served at the expense perhaps of the less business critical ones. You can also set performance objectives that may vary during weekday hours, weekend hours, maintenance periods, so that you can manage the expectations of your customers based upon their workloads and their business needs. At any one time, there's one performance policy active, but you can have multiple ones available to switch at any time. So let's take a look at a couple of factors that feed into this performance policy. The first is the idea of performance in general. This is a very simplistic view, but a very comprehensive view of what real performance is in a nutshell. You have two components that make up performance. One is that your use of resources, whether it's CPU, I/O, memory, and the other is your wait for resources. How long are you waiting to get hold of that resource? Those of you who are DBAs are very familiar with resource waits in AWR reports. One thing you'll note, however, is that resource use is not something that I as a runtime manager or you as a DBA can do much about. It's really a development issue. It's something that the code developers govern. But what I can do is manage resource wait. And this is where quality of service management comes into play, is to both monitor and manage the resource wait, which together sums up to be the application performance. Now this becomes even more important when you start stacking databases on the same physical hardware. This graph here shows you what happens when you start loading more and more databases onto hardware that is running single-threaded core CPUs. You notice here that even starting as low as 50% utilization, the number of cores become critical to my application performance. And at 60%, the difference between one core and two cores is double the loss of performance. My response time will be cut in half if I go to one core. Now, as I'm stacking more and more databases, that becomes a play. But what's even more critical is when I move to the more modern multi-threaded core CPUs. You'll notice the whole curve shifted to the left. No longer were we at almost 100% when things fell off the charts. We actually are now falling off at less than 70%. So this is where you've got to be much more conscious of resource management with the newer CPUs, such as the Spark T4s, T5s, Intel's hyperthreading, or AIX. And the result is one needs a much more sophisticated monitoring and management system if you're deploying on these architectures. So this is a screen out of the policy editor for the actual policies. And you'll notice a few features of this screen. First off, you'll notice that all of the performance classes are listed on the left. So you always specify what the entire performance class grouping. Additionally, you specify the ranks that you actually want to give to these performance classes. How critical is it to meet their SLAs? You can rank it from highest to lowest in one of 5 levels. The bottom line is We're going to make trade-offs based on that ranking. In this first release, we've got response time as the goal objectives. So that's what we're going to manage to. And the fourth column allows you to actually set that performance objective. Now that's something that can be difficult to do in today's environment. And so you might want to start out with using only measure only mode, which is the one column on the right, to get an idea of how well these workloads are behaving. What are realizable performance objectives that you can actually achieve? And then finally, we have the ability to actually run in what I call cruise control mode by accepting recommendations automatically, should you so choose, to adjust those resources so you don't have to wake up in the middle of the night responding to an alert that you've got a problem. Finally, there is the area of server pool allocations where you might want to change the mins, max, or importance of server pools based upon a particular policy, such as you want to do quarterly maintenance, and so you want to rearrange your pools to adjust for that. Obviously, you can have many, many policies and simply activate any particular one at any particular time. And they can be done on a schedule, on a cron job, etc. Once we talk about performance objectives, one of the key things that always comes up is they can be all over the place. What does it mean? How can I look at them in a meaningful way? Well, we ran into that problem in the early forms of the dashboard because there were just too many numbers. You had to integrate all those numbers in real time. We introduced a new metric. Hey, we're a new Oracle technology. We obviously have to have a new metric. And that's what we call the performance satisfaction metric. What we did with that metric was provide a normalized way in which to evaluate performance against the performance objective. So regardless of whether you have a 10 millisecond objective or a 10-second objective, you can actually see how well you're doing against it with a real-time percentage between 100 to minus 100 and a green or red indicator. So it's a quick way, as you'll see in the dashboard coming up, to actually see how well you're doing against your objective without regard to actually having to integrate all of the numbers. So obviously this is a runtime management tool. So it needs to be running continuously in the background, and it does. Once you've defined and enabled a policy set, it goes and starts classifying and measuring workloads in the database, in each database or each instance of the database that is running in the cluster. It's retrieving those metrics every 5 seconds and analyzing them once a minute. Once every minute, a recommendation is produced to see whether or not you actually are meeting your objectives. If you're not, alternatives of resource allocations are surfaced to restore your performance. And you can decide to implement them if you so choose or not. And you'll see a reporting history of those implementations and your historical performance. And this is done once a minute. So we've got a process that is continuous, that is iterative, that maintains the management, that not simply monitoring the system, but actually looking to make trade-offs of resources to keep the system humming along like it's on cruise control. Now, to do that required some sophisticated technology added into 11.2. And so to begin with, we had to instrument the database to be much more precise with regards to its metrics. We actually had to get more clock-accurate metrics with regards to resource weight as well as resource use, and also to be able to categorize those metrics in the performance classes that you specify instead of just simply rolled up by service or database. In addition to those metrics, we also had to be able to get topological information from the cluster in real time. to actually create snapshots of what the cluster looks like at any one point in time so that we can make real-time decisions based on what's running there. Because remember, QoS is making trade-off analysis to keep your database as a service deployment up and running. So Clusterware had to be instrumented. And finally, when you get right down to it, the OS is the governing body here. And so it was important to get metrics out of the OS layer to figure out what actually is happening on the hardware. So all of these metrics and information feed into the QoS management server, which is implemented as a J2E application in the cluster, a single application that's HA protected, and runs a high-level expert system built on Oracle Business Rules to do those evaluations and then surface those to Enterprise Manager Cloud Control. This product works only with Enterprise Manager Cloud Control. Fortunately, it works with the database plugin, so there's no extra licensing fees. But it's heavily integrated into the EM Cloud Control DB plugin. So at the end of the day, what we've got here is the ability to take a look at a cluster of databases, whether a single multi-tenant database or a collection of RAC and RAC1 node databases, and do certain types of consolidation and certain type of database as a service offering, and to be able to control those resources just in time with intelligent trade-offs. So for example, I can actually manage shares of the CPU inside the database with competing workloads that are competing with different services within a database. So allowing me a certain level of schema as a service support. Alternatively, I can actually manage multiple databases running on the same hardware by varying the CPU count between the different databases. And then finally, I can manage the size of the server pools that allow me to actually consolidate different priority workloads that need siloed containers of physical resources to keep them separate. So this architecture gives you the flexibility regardless of the type of database as a service deployment you require, and fully realize the value of your hardware investment. As a third bullet here with regards to the original three objectives that I talked about, and that is protecting the hardware resources, there is an additional functionality that has been delivered, and that is Memory Guard. Memory Guard protects the actual physical resources by preventing actual memory stress related evictions from your cluster. We found that the predominant cause of a memory eviction is memory stress and the result of perhaps the swapper getting involved. And so continuously, while we're getting metrics from the database, QoS management is also getting metrics from the OS and determining whether or not a particular server is under stress. Should that server be under stress, its workloads will be reduced in such a way that new connections will not be made to that server. Existing work will continue and hopefully drain off, and then new connections will be made to those databases on that server, with the result being there will be, in a sense, the ability to recover that memory and keep that server from being evicted. I mentioned that this is all integrated into EM Cloud Control, and this was a number one priority of this effort. Obviously, EM Cloud Control is heavily committed into database as a service, and much of the front-end provisioning, such as service catalogs and cloud portals, etc., are hosted by EM. So it was apropos that we integrate this technology at runtime into EM very, very well. And it's done so in a way that it's very task-centric. So there's EM wizards to actually define and enable policies. There's an actual very comprehensive dashboard, which we'll be showing in a minute, that actually gives you real-time monitoring at a glance. And then there is historical data that is displayed based on different metrics that you can actually view the past history of how well your system has been working against its objectives. So this has all been very much oriented towards a task-based approach integrated into EM. So let's look at this system in real-life action. We have a 4-node cluster where we have divided those 4 nodes into 2 server pools, the back-office server pool and the online server pool. Notice that we have 3 databases in those server pools. 2 of the databases are wholly contained in one of the server pools, i.e. QoS1 and QoS2. However, the 3rd database is deployed across both server pools. This is an important concept because you can deploy a database across more than one server pool and thereby allow for services to run in separate server pools. Notice further that each of the databases have slices associated with them, as you see right here. These slices represent instance caging, and so therefore we have the QoS1 and QoS2 databases instance caged to 4 CPUs, while the QoS3 database is actually instance caged to 8 CPUs. Now these databases have been configured to offer services, which you see in these graphics right here, from the ETL service all the way through the sales service. And these services actually expose the ability to create performance classes like we discussed before. And notice that while each service up above here has one performance class associated with it, the sales service actually has 2 performance classes. That's because we are using another parameter in the classifier, such as the username, to distinguish those people who are just browsing and those people who want to pay me money, the more important customers, and so I've designated that my sales cart performance class. So let's look at this demonstration in action here by starting up these workloads. This is the QoS management dashboard that I showed you earlier. And you'll notice up at the top here we have some general information about what is this current state of the QoS management server. You notice it's enabled, it is running the active policy of business hours, and it allows you to change that policy should you want to do so. Notice also that it has no recommendations necessary because, as you'll see down below here, everybody's green. In the second window here, we have a performance overview. Notice that we have all of our performance classes, but they're not in alphabetical order. They're in order of rank. So the highest rank ones are at the top, and this is governed by the policy in force at the time. Notice also that we have the server pool listings of where the work is appearing for each of those services. This is a live configuration, and therefore we are seeing active transactions in all of those server pools. Now, within this first release of QoS management, we only support, as discussed before, average response time as an objective. So at the moment, all of these objectives are average response time. And finally, you have the ability to actually check off whether or not a performance class has an objective or not as to whether it's measure only. We expect people will start off with performance classes in measure only mode to get an idea of how well they're doing and what type of objectives are achievable in their current deployment. Which brings us to this next column here. This is a very important column where, because we're talking about resource use versus resource weight. Remember that previous slide where I had that equation which talked about application performance, which had the sum of resource use and resource weight. Well, if I look at what happens when I click the blue bar, I see here that I've got a usage of about 58 milliseconds for each transaction in my sales cart PC. That's a very important statistic because that tells me at minimum what my performance objective can be. I can't be better than 58.8 milliseconds because that's the amount of use that on average this transaction is occurring. That's the blue bar. If I move next to the gray bar, you see wait. Now that is that second component in my application performance, the wait for resources. In this case, the wait is about 4.8 milliseconds. So that's a function of how loaded my system is. But once again, the two together are my response time, and therefore I have to manage that wait to meet my performance objectives. And finally, we have headroom. So the green area is how much headroom do I have until I meet my performance objective or exceed it. And as you can see here, we don't have a lot for this performance class. We have about 5.8 milliseconds, but it is still meeting its performance objective, as evidenced by this second column over here, which is showing how I've been doing over the last 5 minutes. I basically have been meeting my business objectives across the board for all my performance classes for the last 5 minutes. This is very useful information, and I have a very healthy system. Thus, down here in the recommendations area, I have no recommendations because all of my performance objectives are being met. But let's change things. Let's go ahead and actually make a demand change to the system. So what I'm going to do is actually increase the demand on the sales cart. My marketing guys just introduced a sale. They didn't tell me about it, so I'm now going to get double the demand. So what's going to happen here? Well, now I see red, literally. You notice here that I now have a recommendation. It's affecting my sales cart PC. And you can see as evidence of that, I've got some red here. I also have red for the sales PC. However, the sales PC is not higher ranked than my sales cart PC, so we're going to attack the sales cart PC first. And you can see at the bottom here a recommendation as to what I should do associated with this PC. So you notice here that the resource that I need to help is the CPU resource. And to do that, I need to demote the sales PC away from the sales cart PC. Now, QoS management always recommends a subtle change first, one that is least disruptive because we don't know how long this surge is going to last. So we don't want to stomp on the accelerator if we just have a slight grade. We want to do things in a more subtle manner. Therefore, we recommend simply a change that only affects the current database. So let's look at the recommendation details here. But first, you'll notice here that my usage has not changed. It is still at 58 milliseconds. However, my wait has gone up to almost 100 milliseconds. And you'll notice also that my performance objective, this blue line here, has been exceeded substantially due to the excessive wait. So what has that told us is if I'm to fix this situation, I need to manage wait. And therefore, what I'm going to try to do is give my sales cart performance class better access to the CPU by demoting competing work away from it. And that's the substance of this recommendation. And we can see here the details of that recommendation listed here. And notice that we've got an action up here. We've got the amount of time we expect the action to take and the benefit that we're going to achieve by making this action. Notice that, if you notice here, that we're going to affect the sales PC, but that's a less business critical PC, but we're going to help out the sales cart PC. Additionally, if I click on the arrow, you'll see I've got a list of actual alternative actions that we evaluated to support this problem. And these are progressively more disruptive. That's why they're given different ranks. Rank 1, rank 2, and rank 3. So notice we have 3 knobs here. One is to move the CPU shares for a performance class within a database. The other is to give that database more CPUs through instance caging. And the third is to actually move a server into the pool. But also, we actually considered other possibilities that we didn't recommend because they weren't as good. And therefore, we give those to you so that you can examine this chart down below for each of them. But let's go ahead and implement the first recommendation. So now we have implemented the demotion of sales PC down in the scheduler of the database. And you notice down here that the CPU wait has improved. It is no longer up at 100 milliseconds. But that's not going to be good enough because we're still red. So let's go ahead, and so we'll get a subsequent recommendation once things settle that we'll need to actually implement. And you notice here that the next one is to promote sales cart once again within the database to even a higher share. So this actually gives it even more access to the CPU. And if we go ahead and implement that, after the settling time, you'll see that we actually improve things. So you'll notice here that the CPU wait is improved. We are still violating. And so we're going to do one final promotion to promote it up to the top consumer group level and see how good we do here. So we're doing that. And we notice here that we've improved things. We're now up to 37 milliseconds, but we're still not there yet. So now we have run out of the ability to move competing work away from each other, and now we're going to actually change the CPU count and steal resources from the other database that's running on in the same server pool. So we're recommending taking a CPU from QoS2 database and give it to the QoS3 database. And we'll go ahead and implement that and see how well that does. And notice that after the settling time, we have improved the CPU wait substantially, but we're still not quite there yet. It's still showing a bit of red, and we still have another recommendation. So now we're going to move another CPU and see how that works. And so we'll see that the CPU wait is going down, and finally it's down to the point where we're now meeting our objective and we now are back in the green. Now you'll notice here that in the meantime we've also helped sales because we've been giving the same database new CPUs. The result is that we float both sales and sales cart. So because the QoS2 database had excess capacity or low demand, it was able to give up resources on the fly just in time to help out its co-tenant, the QoS3 database, and meet its objectives. With the result that in only a few minutes we're able to actually rebalance the system without taking any outages. So let's look at what happened on a historical basis here by looking at the details. You'll notice here that we have all of our performance classes color-coded here. And as you can see here, that this first graph is the PSM, the performance satisfaction metric, and you can see at 11:45 things went in the tank. And why did things go in the tank? Well, you can see that there was an increase in demand that literally doubled on the sales cart PC. The result was both sales and sales cart went down. Now notice that as we started to take action, we started helping sales, but to the detriment of sales cart. We started helping sales cart to the detriment of sales. And then at such time that we actually started impacting the QoS2 database, which had the shipping PC in it, we started helping both of them right here. And the result being that they started to get positive again. So they went from negative all the way up through positive. And you can see that down here in the response time, where the response time got very high and then back down low. Now, what's very interesting to note here as we look at the sales cart PC in isolation is that you see the impact of the demand on its performance objective. But down below here, you see the actual response time and what happened when that demand occurred. But what's very interesting to note is, remembering our equation back in the earlier slide, this response time up here matches the wait time down here, where usage was constant throughout all of this. So this is why QoS management needs to manage the resources that schedule and allow an impact on the wait for resources to bring your performance classes back in line and continue to meet their service level objectives. So in summary, the steps to get to your private database cloud and database as a service deployment are to actually deploy these databases in a policy managed format. Deploy them into server pools and lay out your server pools based upon the business requirements. Consolidate multiple databases on the shared resources using instance caging within Resource Manager, and let QoS management actually manage the CPU count to basically horizontally slice the database on that vertical server. And then ensure that your applications use cluster managed services. This is key. All of this is based on using database services that are managed by Oracle Clusterware, not connecting to the database instances directly. And then finally, enable QoS management to actually monitor and manage your resources and maintain your SLAs. We have created a hands-on lab book that was introduced at OpenWorld in 2013 that is available online, that walks you through an evolution of taking an admin-managed environment and moving it into a policy-managed database as a service environment. And it's a very informative lab. It can be done with VMs on a single 16 gigabyte laptop, and we welcome you to take a look at it. Additionally, we have obviously documentation in the 12 documentation about policy managed databases, about server pools, and a whole book on quality of service management is available for you in the Oracle documentation, as well as information and collateral on and white papers on oracle.com for both RAC and Clusterware, which addresses both server pools and policy managed databases, and a whole page associated with quality of service management that's linked off the Clusterware page. That ends this session, and I want to thank you for your interest and attention.